Hey everyone, let me walk you through deductive arguments. We've talked about inductive arguments, but now let's talk about deductive arguments. Let's start with a definition. In a deductive argument, it is impossible for the conclusion to be false given that the premises are true. So while an inductive argument makes it more likely than not, a good inductive argument makes it more likely than not that the conclusion is true, a good deductive argument will prove or demonstrate its conclusion. What's an example? Well, two very common deductive forms are arguments based on mathematics and arguments from definition. So let's look at the first type. If I put 2 oranges into an empty bag, and then I put 3 apples into the same bag, I can conclude rightly, in fact, I have to conclude that there are 5 pieces of fruit in that bag. You can see that if the first 2 premises are true, the conclusion has to be true. 2 plus 3 equals 5. Now, we also have this term fruit, right? So the second type of deductive form would be an argument from definition. We could argue that a definition requires something to be true. For example, there are no married bachelors. The definition of bachelor requires that that statement be true. Likewise, the prime minister is not a prime number. The definition of prime minister and the definition of prime number require that to be true. So 2 types of deductive form, one based on mathematics, one from definition. The type of deductive arguments that we are going to be looking at in this class are called syllogisms. Syllogisms are going to have statements that begin with all, no, or some. And it's going to be 2 premises that could be more, but usually in a typical categorical syllogism, we're talking about 2 premises that lead to or demonstrate one conclusion. Let's look at the most classic example offered by Aristotle. Socrates is a man. All men are mortal. Therefore, Socrates is mortal. If you accept that Socrates is a man, you accept that all men are mortal, you have to accept that Socrates is mortal. There's no way out of it. It's mathematical. Okay. There are also hypothetical syllogisms. So let me give you an example of a hypothetical syllogism. These are syllogisms that look very similar to the categorical syllogism that we just looked at, but they have one or more hypothetical statements. So here's a classic hypothetical syllogism. If estate taxes are abolished, then wealth will accumulate disproportionately. If wealth accumulates disproportionately, then democracy will be threatened. Therefore, we can conclude that if estate taxes are abolished, then democracy will be threatened. If we accept those premises, they force that conclusion. There's no way out of that conclusion given the premises being true. All right, we'll get to truth versus validity in just a second, but let's talk about a third type of syllogism. This is the third type we're going to be talking about in this class. These are disjunctive syllogisms. These are syllogisms that have a disjunctive premise. So that means an either or premise. Either global warming will be arrested or hurricanes will become more intense. Global warming will not be arrested, therefore hurricanes will become more intense. If you accept those premises as true, you have to accept the conclusion as well. These are deductive forms. These are the 3 types of syllogisms we'll be talking about in class. So now let's talk a little bit about what makes a good deductive argument. And the first is it has to follow a proper form. It must have what we call valid form. So in this class, when we say valid, we don't mean true. We mean a good form. The form, the math has to be correct, right? So we'll talk about how we identify invalid forms, and those are called formal fallacies. Invalid arguments are formal fallacies. There's some classics out there that they sound really good, but when you think about it, the math doesn't work out. The term sound means that we have actually accepted the premises as true. We have evaluated the form of the argument and found no problem with it, and therefore we actually accept the conclusion as true as well. So while you can have true or untrue valid arguments, when we say that an argument is sound, what we mean is it is both valid and true. Okay, so let's talk a little bit about how we might determine whether an argument is valid. All right, so one way that I like to do this is by drawing the argument. So what do I mean, draw the argument? Well, first, in order to draw the argument, we want to identify the form. And what do I mean by that? Well, here we have a deductive argument that has a particular form. This happens to be the form over here. Let me show you how I got this. All A, I've labeled daisies as A. I've labeled flowers as B. I've continue to label flowers as B down here, and then plants is my C variable. So then I just bring this down. Here we've got A, daisies is A, and plants, remember, is C. And I've created this form. Why do I do this? Well, it makes it a little less confusing, right? I start thinking about daisies and flowers and plants and what I know, and I might misconclude that this is a valid form. Okay, so let's focus on the variables instead. Let's focus on this side. And in order to test the validity of the argument, what I want to do is I want to see if I can draw the premises as true, but the conclusion as false. If I can do that, if I can break this deductive form, I've proven it to be invalid, and therefore it's bad reasoning. Okay, what do I mean by drawing it? Well, let me draw this statement. All A are B. So here is the whole group of A, and I have to draw all of them in B. So I'm going to make group B here, and I've got to put all A in there. That's really the only way I can think to do it. I mean, B could be much bigger, A could be smaller, but all of the A has to be in B. Then this one requires me to put all of the B in C. So same thing, I've got to get all of those B captured in my new group C, and that is really the only way I can think to do it. Again, I could make it smaller, I could make it bigger, but I've got to put all of B in C, and now I'm looking at my conclusion. All A are C, and is that true? Yes, that's true, and it has to be true. I can't think of any other way to draw this argument that might lead some of these A to be outside of C. So if I draw this as true, and I draw this as true, and this also has to be true. If I can't think of some way to draw it with this being false, then this is in fact a valid form. Okay, so let's look at another example and test it the same way. So I'm using the same variables here, right? I've just put them in a slightly different order. So this time I'm saying all daisies, A, are flowers, which is B. I'm saying all daisies, A, are plants, which is C. And what I'm concluding is all flowers are plants. All right, that sounds pretty good to me, but I don't want to be confused by what I think I know about daisies and flowers, because what I'm trying to do is evaluate the form of the argument. So I'm going over here to the variables, right? I'm looking at this again. I'm going to draw my same. There's one way I can think to draw this, right? Here's A, and all of them, either bigger or smaller, it can be a different shape, whatever, but all of those A's have to be in my B group. So I've just drawn this. Okay, all A are B. Now I have to draw all A are C. Now this is a little different than the last time, right? Remember, I had to draw C around B last time because it said all B are C. This time it's just saying all A are C. And I'm thinking I could draw it like this. And that statement would be true, right? So I've kept the first premise is true. The second premise is true. Now all B are C. Is that proven by my drawing? Or are there a ton of B outside of C? I was able in my drawing to break this form of argument and show it therefore as invalid. I've now proven that this is an invalid form. So while it could be true, remember, truth and validity for our purposes are two different things. It is clearly invalid. Valid versus invalid. So this is one way of doing it, drawing the argument. In my next video presentation, I'm going to give you all the rules. If you like going through a checklist and checking off different statements, you can evaluate arguments that way. This, to me, is a little bit more intuitive, and it's helpful because I get a visual. So this is one way. You can draw the argument to determine validity. Okay, so let's wrap up with some terms here on our way out. So just as by way of reminder, these are kind of the key terms that we're dealing with here. A deductive argument, remember, is an argument in which the premises demonstrate the conclusion. In other words, if we take the premises as true, then we have to take the conclusion as true. And that is a valid form. right? If it actually works that way, that the premises demonstrate the conclusion, we would call that a valid deductive argument. And it's sound if we actually believe that the premises are true, in fact true, not just believing that they're true or stating that they are true in order to test the form of the argument. If we actually believe them to be true, then we would call it a sound argument. Okay, so next video is going to be some rules. Then we'll give you some deductive arguments, some different types of syllogisms to look at, and have you evaluate them for formal fallacies. Are they valid or are they invalid? Okay, but that's all for today.